All right, everybody, welcome to Opus IVS webinar on Volkswagen Audi crankcase breather systems. In this webinar, we will try to explain some of the intricacies of the Volkswagen Audi breather systems. My name is Andrew Gold. I'm one of the diagnosticians here. I'm sure some of you guys have spoken to me before. I deal with Volkswagen Audi, and I see a lot of these crankcase breather system issues, and I thought it'd be a good thing to kind of review and sort of get some understanding out there so that you guys can do some better diagnosis, and maybe these systems wouldn't seem as foreign to you guys. So with that, let's get started. So in this class, we are going to talk about, the description and operation of various systems and various engines for Volkswagen Audi, some diagnostic tips, some fault descriptions and technical bulletins, of which there are many related to these systems, and some of the differences between a turbo or normally aspirated engine and sort of how that affects the operation of the crankcase breather system, and therefore also how we diagnose them. We have an exclusive webinar offer today. You will get a free battery maintainer with the purchase of a DrivePro ES, our latest and greatest tool. This clean power battery maintainer is very important because anytime you're doing any flashing or really even any diagnostics on modern cars, because they are so heavily laden with electronics, they pull a lot of amperage just sitting there with the key on. And that can kind of mess with stuff if you're trying to do diagnosis. So we don't want to drain batteries. We want to keep that topped off. So we're including that with the purchase. So we'll get some more information about that at the end of the presentation. So let's get right into it. Right here, we got a good old fashioned V8 normally aspirated engine. Very, very simple system. We all kind of know how these work for the most part. And this is the beginning of positive crankcase ventilation and sort of its operation. Very, very simple system. You had some fresh air coming through the engine that collected your blow-by gases from the pistons and also anything that was kind of drummed up from windage. Ventilated it through the other side of the engine through a PCV valve and then back into the engine. This was basically an early emissions control device, and it worked on a very simple setup that this PCV valve would open and close at certain engine RPMs, certain load and vacuum characteristics of the engine in order to recirculate those blow-by gases and crankcase gases efficiently without really having an effect on drivability. So for the most part, very, very simple system and, honestly pretty effective. They worked well, of course, things don't stay the same. Now we have modern engines. We have turbochargers and superchargers. We have innovative thermal management systems. We have direct injection, or even on this engine, we have multi-port fuel injection. And direct injection. We got variable valve timing. We got just so much technology, and the tolerances get tighter. The emissions, get controlled more and more, and because of all of those things, that's going to have an effect on the system. And Volkswagen Audi, just being Germans, they're always looking to improve the efficiency of the system and also reduce the number of components as much as possible. And by doing that, their thinking is that you're going to have fewer components means fewer failure points. And a simplified system will work better than a complicated system. We all kind of know how that works. So let's talk about normally aspirated versus forced induction boost. We like it, especially in the last, I would say, 20 years. Supercharging and turbocharging has kind of become the norm. Because as we know that there is no replacement for displacement, turbo and supercharging is kind of that replacement. So let's get into sort of how a very basic sort of normally aspirated system works, and then kind of build from there. Because as we add more components, the system sort of, you'll see, gets more and more complicated and sort of more complex, has more components. But the operation basically stays the same, right? This 3-liter valve cover is the site of a labyrinth. As the gases come up through here, the oil separates from the air, going through all of these ports. You know, the oil is forced out of the air, and really the goal here is to only, burn your blow-by gases, not oil, right? Just the moisture, just the gases. So, fairly simple system on these early V6s. You had a port from each valve cover. Each valve cover had the labyrinth. Those hoses came together and vented into the intake manifold through what they call a differential pressure regulator, or a pressure regulating valve. That's just basically going to control the flow of those gases so that you're not putting them in the engine at the wrong time, basically, right? Because you don't want to affect drivability. You don't want to, create, misfires or drivability issues, because that's going to drive up emissions. And of course, that's sort of not what we're trying to do here. We're trying to do the opposite. So here's sort of a real life look at this. Your air enters in through here, travels through the crankcase, comes up through the head, comes out of these 2 ports in the valve cover. We'll go back to this picture here because it's a little bit easier to see. Here's your corrugated hose coming up to your pressure regulating valve. Here's the one from the other bank. And it's a pretty simple system, at the right time and the right circumstances, it vents the system, and, it works fairly well. There's not a lot going on here. Some of the common failure points obviously are these hoses. They get brittle. That corrugated plastic, starts to disintegrate. Inside of here is a pressure regulating valve, is a diaphragm. I've seen them rupture before, but for the most part, a fairly simple system. Here is a 5-cylinder Volkswagen engine. Also uses a very similar system. You have a labyrinth through which the gases pass through the valve cover. The pressure regulating valve makes sure that you're not venting at the wrong time, pretty straightforward system. Here is the inside of that pressure regulating valve, and here we can talk about sort of one of the first problems that, and a common problem that we see with these, is that this diaphragm tears. And often what you'll have is, because of this tear, you'll have false air coming in. You'll get false air faults, you'll get lean mixture faults, you'll get misfires. These things really don't like to run with a big vacuum leak, which is essentially what this is. The way that this pressure regulator works is with spring pressure on this diaphragm. But as you can see here, this little port here is actually an atmosphere vent. And that's used as a reference to atmosphere pressure. That's how it regulates the pressure. So, of course, if you have a tear in this diaphragm, you now have a vacuum leak where air sucks in. And you'll often hear these whistling when they're bad in various makes and models. They all kind of work very similarly, and they have a similar issue when or presentation when they failed. Usually you get a high-pitched squealing noise, mostly when the engine is warmed up, and you'll kind of see this issue repeating as we talk about more and more in different engines. Here's a normally aspirated VR6 motor. This little arrow up here points to that reference hole that I was talking about on the 5-cylinder. That little reference hole, when this diaphragm ruptures, as you can see, this would be an old style diaphragm. See how kind of flimsy this is, and it's torn here. This is the newer, updated style one where they've done some nylon reinforcement in the diaphragm material to prevent that tearing from happening. But again, that's using an atmospheric reference to regulate the pressure inside of the head. Inside of the breather system. Now, also in here, you have some oil air separation. And this is kind of a good instance of where they use a cyclonic separation system. These little cones here are actually part of this cyclone system. Now, where do we know this from in kind of daily life? Dyson vacuum. They love to talk about this cyclonic action. Well, we use that same physics principle for oil air separation in a lot of our vehicles. Here we have a example of that. Oh, get this to play. It doesn't want to play for me. Well, what you should see is all of these particles moving here. The yellow particles would be our oil, and the gray particles would be our air. As the air and oil come into this system, we have a swirling action. That swirling action pushes the oil out of suspension in the blow-by gases. Our blow-by gases continue to come up this tube, and our oil, steadily concentrating on the walls of the cyclone here, will drip down and end up back in our oil pan, back in the crank somewhere. Because obviously we do not want to burn our oil. We want to save our oil and separate it from the blow-by gases that we're trying to get rid of. I apologize that this isn't operating or isn't moving. This is a really cool slide otherwise. Now, why do I have a can of dust off here? Well, whenever I talk about these cyclones, obviously in that picture, that was kind of a representation of one. Those cyclones are very small. And when you have air, a gas, moving through a fixed orifice, just as like when you are using your dust off here to blow stuff, that gets very, very cold. You have a gas going through a fixed orifice, very small. When that gas expands, it pulls your temperature down, right? And you can get a freezing of the water mixture in the vapors, and that can lead to all kinds of issues. So it's something to definitely kind of keep in mind that that leaks in this system can cause freeze up if you have a lot of moisture and very cold temperatures. I have seen these things freeze up. I've experienced it myself on a Volkswagen GTI I had, where cold start, I was just burning tons of oil, and I found that the thing was full of water and it was all frozen. And once it warmed up, everything worked great. So, I mean, it is something to keep in mind. But let's kind of move on to turbocharging and supercharging and forced induction, because what that does is kind of change the way that we have to vent this system, because now we have to worry about boost in our intake manifold. We no longer have only vacuum. And so we have to have some way of regulating when the blow-by gases are put into the system, because if we are not careful with that, then we are going to be putting boost into the crankcase, which is never a good thing, right? We're trying to get the positive pressure in the crankcase out, not add to it. And you can see this is kind of one of the first systems here on a turbocharged engine, and you can see there are many, many components. We have a coarse oil separator. We have lots of check valves and hoses, a pressure regulating valve. These systems have, just a lot of components that are all areas where things can get buggered up. We got one-way check valves. All these hoses are rubber. You'll see they get all kind of mushy and start coming apart. And you'll see, and that's mainly because oil has additives in it. And oil itself is just sort of corrosive to rubber now and plastic. Now, obviously, they use rubber and plastic that's meant to be in contact with oil. But that stuff is really only going to last so long. And as these things age, you'll start to see these hoses and pipes and check valves and stuff all start really, gumming up and having trouble. And I would say one of the most common things on these 1.8s, whether it's transverse or inline mounted, is actually this little elbow hose coming off here to this T-fitting, and then this check valve. These things they crumble. I mean, they come apart, and more often than not, what'll happen is you'll go to replace these things, and you'll find all of these hoses and tubes and everything are just totally, just coming apart and I mean, you look at them wrong and they crumble. So you'll end up basically replacing all of these components. And that would be my suggestion. If you ever really get into one of these, just do them all, because of course the one that you're not going to do is going to be the next one that comes back, leaking, and you're going to have an unhappy customer. But, you know, this is kind of one of the first instances where they had to think, okay, you know, we're going to be under boost. We're going to have to put some check valves and things in here in order to prevent that boost from getting into the crankcase, because that would be very bad. Here's a 2.7 twin turbo V6. It's a 5 valve per cylinder twin turbo. This was cutting edge when it came out. You know, but again, we have a very distributed system here. You know, we have our pressure regulating valve. That's what this is. Somebody was wondering. We have our air distributor that controls the flow from each valve cover, and also determines the point at which this is going to vent. This is kind of one of the first times when they, you know, decided that, okay, we're going to vent when we're in normally aspirated mode, we're going to vent right into the manifold. When we are in boost mode, we're going to vent before the turbo, where there is vacuum. Basically, they want to vent wherever the vacuum is occurring, right? If you have boost, you can't vent. You know, and these systems I have seen, again, as they age, all of these hoses, you know, these pressure regulating valves, they really get all gummed up. The additives that are in fuel and oil these days really just, you know, do a number on these plastics and rubbers, and especially the diaphragms and stuff. And you know, you'll see that when these diaphragms rupture internally, you may not have an external leak, but you may have an internal leak, and you'll get a lot of oil because the flow is messed up. You're not getting good oil-air separation, and these things will be burning a lot of oil. You'll have a ton of oil, you know, going down into your turbos, and you may even have, you know, some smoke coming out of the tailpipe. So, you know, I mean, these systems, obviously, we're not seeing that many of these anymore, but it is kind of good to know that this is kind of where the rest of the systems come from, right? Volkswagen Audi is all about incremental change, you know, and they kind of have a system and they make a little change to it, and then the next generation they make a little more change, you know, and they refine the system over time. So let's see here. So we'll move on to this is a 2-liter turbo. This is a very, very common engine in Volkswagen and Audi for a long time. This is the belt drive, early belt drive 2-liter engines. You know, this is kind of the first instance of them trying to kind of smush all of these components together and have fewer overall components. But of course, when you have fewer components, the components you do have are more complicated. So as you can see here, we kind of have a lot going on, but I'll try to kind of go through it. You have your primary oil separation is actually part of the oil filter housing here. So this is your coarse oil separation. There's a labyrinth through which the air flows. You know, your big droplets, ones that are not really suspended in the gas mixture, kind of fall out of suspension here very easily and are routed back to the oil pan. Your blow-by gases travel up this hose here and into your what we would call the pressure regulating valve, even though really that's only just this one part here. So your blow-by gases come up through here, and then this is kind of where it gets interesting. They go through another labyrinth here in the cylinder head. Now this labyrinth is for more fine oil separation, whereas our coarse oil separation was handled down here. So as the air flows through here, right, it's forced to make a series of turns, especially right here. And that really makes the oil kind of flow out, you know, come out of suspension. But here is where we get into the issue of normally aspirated versus forced induction or boost. This pressure relief valve, or pressure regulating valve as we call it, is kind of your determining factor here. When you have boost, we have this gas outlet from the valve to the intake manifold. When your intake manifold is under boost, so is this hose. And as that boost comes into here, it redirects the flow of those blow-by gases. Instead of being in the intake manifold, they now travel out of the pressure regulating valve through the valve cover, right, through a channel in the valve cover here, right, and into this gas outlet here for the turbocharger. Now that component is a metal pipe, and that vents then down into the turbo. So when you're under boost, you're venting into the intake side of the turbo, right? And when you're in normally aspirated mode or you're under vacuum, you're venting right into the intake manifold. And this is kind of what I was talking about, how we do this switching between normally aspirated mode and boost mode. And it's constantly going back and forth. We have a couple of non-return valves, we have our pressure regulating valve, and this thing is kind of going back and forth and back and forth and back and forth, right? As you're giving it gas, you come off the gas, right? Boost builds, boost, goes down, vacuum takes over, and you kind of bounce back and forth between those. And that was a fairly successful system. However, as with most things like this, they came out with an update. So the easiest way to tell and I'm talking about original parts. I'm not talking about aftermarket parts because they may look a little different, but kind of the basic right off the bat, easy way to tell if they had the original one is looking at this pressure regulating valve. As you can see on either of the new updated ones, where you have this VIN split, you can see that pressure regulating part of the valve looks a little bit different. The pipe that leads down to your turbo is a little different. In fact, on the later ones, they actually added a valve here, which always seemed a little interesting to me because you're never really under boost on the intake side of your turbo. However, I think they did that to prevent any blow by coming by if you did have some kind of an abrupt stop of air movement. You don't want it to travel back up this pipe and pressurize the system. So, obviously these things were plagued with sort of the same issues that they all are, which is that inside of here you have a rubber diaphragm, and those diaphragms rupture. And once that rupture happens, you're basically no matter what you're doing, you're either pulling vacuum through the valve, or worse, you're putting boost pressure through the valve and into the turbo, and you're losing boost. So either way, not a good thing. Now there is sort of a related TSB here that I wanted to talk about on these early engines. Here's the valve cover. As you can see from before, we have our port inside of the valve cover, right? Normally our pressure regulating valve would be here, or our breather valve would be here, right? The port would come through here around the number 2 cylinder spark plug hole, and this is where our hose would be to vent. Well, the problem is that the way that this system is built is using a ultrasonic welding technique for plastic, and I guess they just weren't that good at it, because a lot of these have an issue where the plastic starts to separate, as you can see here with the screwdriver, or right here. And where is that separating? That is separating right along this line here for the venting of your breather. So now, here's the part where it goes a little weird. In the TSB, it says, do not exchange the cylinder head under this condition, as warranty will be declined. Gaps in this part are not a defect. I don't know how that could not be a defect, but that's what they say. Up to 2.2 quarts of oil in the intercooler are within normal conditions and do not require further action. Again, something I disagree with. That seems like a lot of oil. If you're sucking it up through here, that doesn't sound right to me. I just don't get this TSB. This part of this system just doesn't make any sense. This valve has to be able to vent through the valve cover. If you're losing air through here, or worse, maybe you're sucking air through here, then it's not going through the rest of the system correctly. You're not getting enough flow through your labyrinth for good oil separation. So I'm not sure. I don't know why they think that this is an okay thing and that there should be nothing done here, because I think it should be replaced. And I've seen plenty of them that have will have faults for lean mixtures or air in the system, and you have no external leak, I'll just back up here. You'll have no external leak, but what you actually have is an internal leak. And you're getting false air through this valve cover. So, I mean, if you, if you have one of these systems and you're sure that it's tight and that you got no external leaks, but you're still getting these faults as if you had the vacuum leak, you might think about pulling this valve cover off and checking this thing and seeing if it's cracked wide open, because you could have a vacuum leak. It's just internal. It's not, you're not pulling air from outside per se. So something to definitely keep an eye on. And I don't know who wrote this TSB, but that doesn't make much sense to me. All right, let's move on to the chain drive 4 cylinders. Obviously, I have an Audi one here, but it's the same in the Volkswagens. Very, very common engine. This was kind of the beginning of the chain drive systems, and once again, they're trying to eliminate system components in the system here, right? I mean, we don't even have a valve cover anymore per se, right? We have the cam cradle, which is sort of part of the head. It's, your cam journals here. Obviously, this head doesn't have any camshafts in it, but I mean, it's a very integral part. And so instead of having a valve cover, now we have this valve, this oil air separator / pressure regulating valve. As I'm sure many of you are aware, they had a lot of problems with these original ones, and I'm talking about only OE manufactured ones. The original ones were black plastic. And then after they were having lots of issues with these and issues with oil consumption, they went to these updated ones, which sort of the easy way to tell was that it had this white plastic here. Now, obviously, we would really do it by part number, but kind of a quick, quick and dirty way of telling if they've had the updated valve, which was actually part of a recall for a little while on some vehicles, where they actually recalled these vehicles to update them. It's kind of an easy way to tell, because one of the major things that was done when you switched from the original to this updated valve was that you actually had to reflash the ECM, because this valve runs much lower crankcase vacuum than the original ones. They lowered it, I think, by about 100 millibar. So the reason that this kind of all came to be, I mean, besides these failing and having issues, was because of high oil consumption. That was kind of the bulletin that required some addressing, right? This is the complaint that a customer would come in with, and I will tell you, from 2009 to 2011, I did very, very many of these at the dealership. It was a very common thing. Oil consumption was a big problem, and they came out with this TSB. And what was the TSB? The TSB was to replace the breather valve. When you replace the breather valve, you also had to replace the crank pulley bolt and seal. And I mean, you can see that basically every CAEB engine, A4, A5, Q5, they all are going to have this issue at some point and have to be updated, to this system. Now, don't go off of this. You're always going to want to check your latest and greatest, because they do often update these technical bulletins. Even ones that are 8 or 9 or 10 years old, Volkswagen Audi is still updating them. So you really do want to try to, get your hands on the latest and greatest, because there's different software versions, there's different part numbers. But yeah, I mean, this breather valve, in combination with a maybe poor design decision on Audi's part, with pistons and piston rings, is a major cause of oil consumption in these engines. I will say that most of the time, replacing this valve, and even though they lowered the crankcase pressure, and you replace the valve and the seal and everything, they would still come back 500-600 miles later, burning a ton of oil, and we would end up putting pistons in these things. So, not uncommon to see these things burning a lot of oil. So let's talk about our V6 progression here. We start with that normally aspirated 3.2. We moved to a not much different version of that one, basically adding the Audi valve lift system for valve timing and lift. And then we moved into the newer style 3-liter supercharged V6, and then this would be the second generation. But for the most part, these systems are all kind of operate the same, and as is sort of tradition for Volkswagen Audi, these systems are slowly and sort of moderately changed as they go along, right? They don't make huge huge changes, sort of smaller, trying to refine the process. So let's talk about the 3 liters, because these had a lot of issues also, and they had the same kind of issues that the 2 liters had, which was that they pulled too much vacuum, and their solution was to lower the amount of vacuum, right? Lower your crankcase pressure. So here we have another system where they've kind of smushed a bunch of things together. You have your oil separator, you have your pressure regulating valve, you have your connection right to the supercharger, you have your vent hoses that come from each valve cover. Your primary oil separation happens right here in the valve cover. Again, you have a labyrinth system through here. Your gases come through here. Their further oil separation takes place, and then they are vented. Now, the fresh air supply is going to come down from this PCV line with a check valve in it, and it's going to come down. It's going to go under your supercharger, snake around, and then into the valve, or your valve here. That's your fresh air supply. Just something to note: there is coolant running through here. This is a coolant line that starts here, comes to the right side of the block and the left side of the block. So when you remove this, there's going to be coolant in there. What I always did was use my oil extractor, and I would just kind of shove it down here in the corner. And as I loosened this thing up, I tried really hard not to pull it all up at once and drop all the coolant out. I would just kind of let it out slowly and suck up all the coolant, because once you're in here, you really don't want your coolant and your oil to mix. Obviously, that's not good. So this picture here, I just wanted to show you kind of what was happening inside of this valve. You have a pressure regulating valve, very, very similar to all the other pressure regulating valves. You have a atmospheric reference hole. You have your diaphragm and a spring. Just something to note in this picture here, you'll see that you have that same cyclone part as part of your oil separation unit, which is right here next to the pressure regulating valve. So this uses that same system, that cyclonic action, to separate your oil from the blow-by gases, so that you're not burning oil, just the blow-by gases. Now these also had a very similar issue with that oil consumption. And we replaced these a lot too. A very similar circumstance: you would replace the valve, you would have to update the ECM to tell it that you've reduced the crankcase pressure. This picture, I just wanted you to kind of see that there is the connecting piece that vents into here. Now, something that you may notice about this system is that even though we are running boost, because of the nature of the supercharger, you never have boost on this side of the supercharger. And so you can vent to this hose all the time, because you're always under vacuum here, right? As the supercharger is spinning, you're sort of always pulling vacuum, right? So very easy on this system to vent it right here. There's no switching between boost and normally aspirated modes. And that kind of, I guess, keeps the system slightly simpler. Something to note on these systems: after you've replaced this pressure regulating valve, in order to do that, you've removed this lower intake manifold with your flaps. Very, very important here. Achtung. When you put these back down, you must hold these flaps open. Now, the best way to do that would be to put a vacuum pump on here and just pump it up. These these flaps will open, and then you can put the assembly back down. The reason that you're doing that is because it's a little hard to see, but in the head here is a little divider. And if you put this assembly back down without holding the valves open, then what happens is the valve actually gets caught on that divider. And instead of being able to swing down when it's commanded, it gets stuck. And you'll get faults for the intake manifold runner stuck closed. And you'll have to pull the whole supercharger off again. You'll have to pull this thing up again. I mean, it's, not a mistake you want to make. So if you learn one thing from this class, let it be this. Do not put this back in until you hold open these valves. I like to just hold them open with my fingers, but I will warn you, you're going to want to open them all at the same time. Do not try to open all three of these flaps by just pushing on one of them, because you will break it. So, what sort of led to this issue that they had with pistons? And part of it is because they ran so much vacuum in the crankcase system, and in combination, they tried to use these low friction oil control rings, which you can see are not like most oil control rings. Most oil control rings are a three-piece. You have like a top, right? Then you have your spacer here, and then you have a bottom one. These are kind of this strange I-beam system here with the spring behind it. As you can see in some of these pictures, I mean, this is what would happen. You can see the oil and the carbon just starts to cake inside of this. Right, here's one that's not terrible, so you can kind of still see the oil passages here. But I mean, look at some of these other ones. I mean, they just get all clogged up, and this leads, of course, to low compression, to heavy oil consumption. Really bad stuff. Now, what can you do about this? I mean, and at the dealership, we would run an oil consumption test where basically we would measure how much oil was in the engine. We would let the customer drive for a minimum of 600 miles. They would come back and we would check the oil again. Now, in the early days, we would actually do this by weighing the oil. Right? We would drain the oil, weigh it, and then put it back in. And then when they came back, we would drain the oil again and weigh it. And whatever the difference was, there was a calculation, and basically you would call Audi and they would say, okay, that's too high. And you would replace the pistons. And the new pistons would have totally different setup. It's a different piston. It's a different coating on the skirt. It's a different ring setup. I mean, they really changed the design of it. But barring that, what we have seen a few times is using this AC Delco X66 upper engine and fuel injector cleaner. If you have one that's kind of like this, where you got some carbon buildup, but it's not quite so bad yet, you can put a couple of drops of this in each cylinder, let it sit overnight. And this stuff will hopefully, maybe, break up some of that carbon and give you back some of that compression. I mean, there's no guarantees, but honestly, at that point, you're looking at pistons or a motor anyway. So, if it works, you're a rock star, and if it doesn't, you're not really any worse off. So just something to keep in mind. Some of the other problems with these 3-liter pistons, I'll show you here in the next slide, is carbon scoring. This is actually one that I did. I mean, you can see how bad this carbon really gets on here and on the piston, on the face of it, and you can see this scoring. Now, this scoring, you can't really get a nail in it or anything, but this is actually an iron sleeve that's pressed into the block, and so it's very, very thin. I think just about a millimeter thick. I mean, there's not much to it. So even though these lines don't look that bad, and you can't really get a finger in them, I remember this on this vehicle. Audi told me, I sent Audi these pictures, and they said, put pistons in it, and I said, are you sure you want me to put new pistons on this? Yep, you can do it. I was like, do I have to hone the cylinder or anything? Nope, just put the pistons on. So, I did what I was told. This is about 6 weeks later when the engine comes back. Same exact engine, same exact cylinder. And you can see here that, that scoring that did not look that bad to start is already starting to come back. At this point, this thing was burning a ton of oil. ran like crap, misfiring pretty bad, and you know, ended up getting a long block. So just kind of an example of what can happen here when you don't have a good breather system. You end up putting a lot of blow-by gases and a lot of oil back into your motor, and that's no good. You know, you end up with these deposits and stuff. I mean, look at this. Even on this one, this is a brand new piston. I mean, only 6 weeks later, maybe not even. You know, probably about 1,000 miles, and the guy didn't drive it that much. And I mean, it went downhill real fast. So just be aware of that. You know, that you know, you want to get a good look down inside of these cylinders if you have a carbon issue, because the carbon could be in the cylinder also, not just on your valves and injectors and stuff. You know, this is, I've seen this get pretty bad before. So again, I just want to throw this picture in here because, you know, we have this sort of progression from the normally aspirated into the supercharged engines. This here is now what they call the Evo engine. It's not much different from this, but it's different enough. You know, and let's talk a little bit about that system, because you can see how they've sort of recognized maybe some of the issues that they were having and done some things to change the operation. So even though it's basically the same, you'll see that there's a couple of things. So you know, first of all, right, the pressure has been dropped down to 150 millibar. That's pretty standard on most of them now. You know, but that crankcase pressure number can be kind of all over the place for different engines and different engine codes, and it's very hard to find that information sometimes. I know that we've been compiling at Opus IVS some data of our own, just that we've collected from you know, some of our you know, techs that are out there in the real world, and we, you know, try to access that. I believe that we're going to have a handout at some point, and we're going to try and get you guys that information so you have something at least to go off of. You know, it's not official from Audi, Volkswagen, but, you know, it is, you know, the best data that we have at least. So I'm not going to go through all of this in here. You know, you guys can come back and read it word for word. But a couple of things that I like to note about this system. First of all, you have that same kind of labyrinth, right? You have it come down into this breather, you know, system here. You still have your air coming in from the outside, but what they've done here is put this crankcase ventilation shutoff valve in, and that's kind of an interesting thing here, because what they've basically done by putting this here is when they shut this valve, they stop the flow of crankcase pressure or crankcase ventilation. You know, and why would you want to do that? Well, there are some circumstances where that might be good. You know, the main thing here. Oh, the other thing to note is that you only have one vent pipe. The bank one does not have a labyrinth in the head anymore. In the valve cover, there's no connection to it. You only have one hose, and it comes on the driver's side. So, you know, trying to simplify the system, reduce the number of components, you know, and I imagine try to make it, you know, operate a little bit better. Something else to note on these is that this vent tube here is insulated. Now, remember when I was talking about Mr. Freeze back there and the dust off? The reason that they're doing this is because of when you have water in this system, you know, in these swirl chambers and in these check valves and everything, it doesn't take a lot of water to freeze up in order to prevent a valve from opening, or maybe prevent it from closing, or, you know, just kind of in general messing with the system. And so, you know, one of the reasons why they put this whole system down in the V here is to keep it warm. One of the reasons they don't mind the coolant flowing through here is because it keeps it warm. Right, heat is going to be your friend when you're trying to separate oil from air, you know, and prevent that freeze up, you know, from occurring. And I will say that you don't really see the freeze up as much on the newer vehicles as you do, excuse me, on the older ones. So the other thing to note on these here is that this vent pipe is permanently connected to the valve cover. I'm not sure exactly why, but on the older systems, there was a little thing you could pinch here, you could pull it off. It was real easy. Apparently, the California Air Resource Board was not a fan of that. I imagine they said that you would get some leakage through there or something, and that would create some some emissions. So this is kind of the system that they came up with. Now, that shouldn't really make too big of a difference to us, except, of course, if you have to take this valve cover off or take this hose off. So, what I have found is that you can kind of leave this connected, unbolt your valve cover, and then just kind of rotate it up out of the way and keep this connected. Now, obviously, you're just going to want to be careful you don't put too much strain on this, because it is just a corrugated plastic hose, which, as we know, is not going to last forever, especially if you flex it a lot. My other suggestion is that you don't really want to, if you guys are in the colder climates, you really don't want to touch this stuff if it's really cold, because all of these plastic pipes and everything, they get real brittle when they're cold. So just be aware of that. If you have to, let this thing warm up a little bit if you can before you start trying to pull these things apart, because the plastic doesn't do well with the real cold temperatures. So this is kind of the latest and greatest of the supercharged V6. Now, obviously they're sort of moving away from that supercharged engine, and they have moved into a turbocharged hot V engine. Now, this is a pretty big departure from the design aspects that they've had. There's the 4-liter, the 3-liter, also in the RS5, the 2.9 liter, which is basically the same engine but with 2 turbos instead of 1. Really sort of changed the design of how these engines work, right? You have your hot V, right? Your exhaust comes onto the middle of the engine in the V. Your intake is along the outside. That in and of itself, that reversal really changes the design of these engines. However, the crankcase breather system works almost the same. And you'll see that this is kind of a reoccurring theme. These systems sort of work the same, have basically the same components, just sort of adapted to each engine separately. So I'm not going to bother reading through all of this. I'm just going to hit the highlights. The highlights are we're at 150 millibar crankcase pressure. That seems to be kind of where they're going. So at least now we have a number, that we can check against. But this thing really operates in the same way. You have your blow-by gases come up from the crank here, and from the block. They come up through the valve cover and then into this separate oil separator module that's bolted onto the valve cover. Let's go to the next slide here. I'll give you a little bit better view of this. So this operates in basically the same way. The blow-by gases come up in here, and they hit what they call an impactor. Now, this is kind of replaced in a lot of ways on these systems the cyclonic action. What happens here is it's almost like a little filter screen kind of thing, that as the blow-by gases with the oil come through it, those screens force the oil droplets to kind of come together and form, from very small atomized droplets, form these bigger droplets. And of course, those bigger droplets, as the air is coming around here, they can't make their way up to the pressure regulating valve or pressure control valve. They fall out of suspension, and then they go through this gravity valve back into the head, and drain back down into the system. So, kind of a little bit different setup, but essentially it operates the same. Something to note on here is that on this system is that because it's turbocharged, right, we have to have some control over when and where this thing vents, and then also where it gets its fresh air supply. So in the PCV system here, or what they call the PCV system, I would call all of this part of the crankcase breather system. But here's your fresh air supply. And that fresh air supply comes from two places. It comes from the normally aspirated side, or the intake side before the turbo. And then it also can take it from after the turbo on the boost side. And, there's some check valves in here, non-return valves, and that's going to kind of determine where the fresh air is coming in to obviously, flow up through the rest of the system. So your fresh air comes in through here, under the turbo into the block, right, circulates around down here, and then, as in this picture, right, comes then back up and through our oil separator module. So, works almost identical to the rest of the systems. Again, you'll see this kind of theme of how these systems work, maybe slightly different for different applications, but basically operate the same. The other thing to note here is that this charcoal canister connection, this is actually your evap vent valve, or vent hose attaches here after your purge valve, and it actually vents through this system. So that's kind of something to know too, that that connection is through here now and not straight into the manifold. So just something to kind of pay attention to. Now, I haven't seen a lot of these engines with issues, but I could tell you from experience where I would think we're going to have issues. And of course, the first thing I'm going to say is this pressure control valve, the diaphragm here. I'm sure that they're using this updated, material with the, the fiberglass woven, material for strength. But I'll tell you that the oil that your customers use and the fuel that they use all have additives in them, and a lot of those additives are not so kind when it comes to this rubbery, nylon diaphragm material. And I just see that this is kind of going to be the issue. Now, luckily, they haven't buried the frickin' thing underneath the turbo. So, at least if we do have an issue with this, it's going to be sort of easy to get to this module here. And of course, because of that, it'll probably never break. So good for them. Let's hope. So let's go into the 4-liter V8 twin turbo direct injection engine. That's in the S8, in the S7, the S6, the SQ5, the RSQ8, I believe. All have versions of this twin turbo 4-liter V8. And these use a very similar system for crankcase ventilation. You have your pressure regulator / oil separator, and then in the V here underneath your turbos. So of course, because it's impossible to get to, it's going to fail. And then you have this plate this is in the actual V of the engine, where your valve plugs into for the various, breather systems, right? Whether you're under boost or vacuum, obviously that's going to vent in a different place. So I'm just going to kind of go through sort of the big points of this, and how this system works. It's very similar to the rest of our systems. The red here is your blow-by gases and to be ventilated. They travel up through the block, through the head, into a hose in an integrated port or hose in the intake manifold, right? This is a hot V, so your intake is on the outside, right? It flows up through here, right? And into this hose and into your oil separator module. On this side of the head, it comes up through here, and it vents right onto this side. So there's only one intake or one location that this is coming up, right? So it comes up from both sides, but it then, comes into this one pipe. The oil comes into this, into the valve here, and this is where your separation happens. This is where your impactor is to assist with that, droplet formation. Coarse and fine oil separation happens through here. This green is your oil pathway back. So when the oil is done separating, as it collects, it drains back into the block. There are a couple of check valves in the bottom here, gravity valves. So, a certain amount has to build up before it actually overcomes that valve and drains back. But, this system, has kind of a couple of interesting features here. One of the first things that I like to talk about is that they actually have a TSB about this, that this system only vents into one of the turbos, the driver's side turbo. So often what will happen is guys will get the turbo pipes out and they see this and they're like, holy crap, this thing is all dirty. And this one is nice and clean. What's going on? We must have something going on with this turbo. This is totally 100% normal. Or I shouldn't say normal. I should say this is totally 100% by design, because the system only vents into the one turbo. Obviously, all your blow-by gases are getting burned or are shooting through this turbo. Now, personally, I don't like that, because what you're doing is you're shooting oil and blow-by gases onto a nice hot turbo. I mean, of course, it's gonna discolor it. You're gonna get some carbonization. You're gonna get some buildup here, and then meanwhile, you got a nice shiny, perfect turbo over here. So a little bit of a weird design, but it is what it is. That's what they do. So let's talk a little bit about how that ventilation takes place and when it takes place, because that can also assist with diagnosing, because this thing is not going to vent all the time, right? You guys can come back and read this word for word, but basically the gist of it is that at different different pressures, it's going to vent differently. It's going to vent differently if you're at idle, than if you're off idle, than if you're at full throttle. In fact, this system does not vent at all if you're at full throttle. It basically shuts off the breather system if you're at full throttle, and that kind of makes sense, because you're pushing a lot of boost with the twin turbos and the V8 and a lot of volume, and how long are you really at wide open throttle? It's not long enough to build up enough gases that this system can't be stopped from venting for a few seconds. So just something to kind of know about, that this thing does not, not always venting, and certainly not at wide open throttle, full boost. It is not gonna vent. But definitely be aware that this system does only vent into that one turbo. So just know that turbo's, whenever you get this thing apart, is not going to look the same as the Bank 1 turbo, and that is normal. So they have TSB about this. The complaint that you will get very often, and you'll hear it usually when the customer pulls up, is a very loud whistling noise coming from the engine. It's usually only at idle under high vacuum. Usually if that is the case, what has happened is that membrane has ruptured, and you will need to replace the entire breather system. Some of the faults you may get is this P2279 intake air system leak, or a P0507 idle control system RPM higher than expected. If they drive this thing long enough with this fault, you can get lean mixture faults. But usually they know right away, because this thing is squealing. So let me show you an example of that. Let's see. Hopefully it's not too loud here. How do I get this to play? So as soon as he pulls the dipstick tube, right, you are now don't have enough vacuum in there for the valve, the diaphragm, to make that noise. So that's kind of the noise you'll hear, that real high-pitched squealing. Let me turn that off because it's annoying. So if one of your customers pulls up and you hear that noise coming from their car, you pretty much know that you're going to be making some money. and you're going to be replacing that valve. So let's talk about some of the common things that happen when these systems fail. And I would say one of the major things that we have when these things fail is excessive carbon buildup. I mean, really bad carbon, enough to hold valves open, enough to cause scoring on cylinders, enough to affect the compression ratio in your engine. I mean, these things can really build up depending on a lot of things, but mostly on lack of service, lack of using good oil, and a lot of short trip driving. A lot of these, issues, the short trip driving is just a killer on these direct injection turbo and supercharged systems, because they never get up to operating temperature. The breather system never really gets cooking, in the sense that you're getting good separation, and you really just start, burning up oil. And all of those deposits, because we have these direct injection systems, we got nothing spraying on these valves to keep them nice and clean and shiny, and those deposits just build up and build up and build up, enough that they actually have technical bulletins about cleaning them. Some things to know, you can use this special tool, Zip Tie 365-4301. Works really well and will not scratch up your valve or your intake runner or anything like that. Obviously, that's not a real special tool, guys. That is just some zip ties. What I like to do is usually take just a few zip ties, cut the end off, and I stick them in my drill. And then I very slowly just drill around in there with the plastic zip ties. Works really well for getting that crap out of there. But I'm sure you guys, most of you are probably familiar with doing decarbs on these. A lot of that carbon buildup issue is due to the crankcase breather system not operating correctly, and or not separating your oil and air well. And that's usually due to a flow issue, because in order for that cyclonic action to work, and for those labyrinths to work, you have to have a good amount of flow through there. Right, and you got to get up to operating, temperature in order to really pull that oil out of suspension, and get it to flow back in, down into the pan and into the engine. So something to keep in mind, when you're cleaning these things out, is that it didn't just get bad for no reason. It could have gotten bad because you have other issues, and that's something that you're going to want to possibly address. The other main thing I would say about this is be careful with your solvent. You don't want your solvent, if it's really bad and you're pouring some solvent in there, you don't want it to contact the bottom part of the valve guide, because obviously, as you know, between your valve guide and your valve stem, you have a gap that usually there's oil in. Well, that gap is very, very thin, and if you fill your solvent up too high through capillary action, that solvent can creep up that valve guide and damage the seal or damage the shaft of the valve. Definitely something you want to avoid. So just something to kind of be aware of. Here's just some examples of what it looks like when you get real, bad carbon. And honestly, this one isn't even that bad. I've seen ones where, you could barely see that there's any air getting in there. It's pretty amazing. And let's not forget, because we have a direct injection system, if you have really bad carbon buildup like this, it's a very good chance that you have pretty bad carbon buildup on your intake, on your injectors, and on your flaps. And that can cause issues too, So if you pull one of these things out and it's really gummed up and really bad, you may want to take a look at these injectors. And if they look like this, you may want to replace these, because I will tell you the holes on these injectors are very, 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 very small. And it does not take much to not really so much clog them up, although that does happen. But really what you're worried about is your spray pattern. If it affects your spray pattern, that can affect the atomization, and can lead to all kinds of lean mixture faults, rich mixture faults, rich misfires. You could get cylinder wash down. It could go downhill pretty quickly. So I always like to, if I have a carbon issue, check and then, possibly replace these fuel injectors. So something to keep in mind. Let's talk about a couple more TSBs, especially on the 3 liters. That same noise that you heard, that high-pitched squealing, which is awful, the banshee noise, you can get that on the 3 liters also from that PCV hose. What will happen here is they say if the hose clip is overstretched, this can lead to leaks in the crankcase breather system. That's probably just because Klaus really cranked down on this clamp here, and this is just a little rubber elbow piece, and he clamped down on that thing and he tore right through the boot. And what will happen is now your breather system, instead of sucking nice fresh clean air from right after your filter, before the throttle, now it's just sucking in dirty air and whatever crap is falling down underneath your supercharger. And it's messing with with your crankcase pressure and stuff, and you'll get squealing noises. You'll get this P052E00 fault, which is literally a PCV performance fault. That's how precise these things have gotten now. It's they can tell if the PCV system is not operating correctly because it knows exactly how much vacuum should be created in the system. There's another TSB for the same exact fault, of course. That makes it a little confusing because you could have multiple issues. Also, noises from the engine compartment, a squealing noise or a whooshing noise from the breather system, which, of course, on this car is under the supercharger. It's not like you can look at it while it's running, right? And because to really get a good eye on this thing, you're pulling the supercharger off, in which case you're not running the engine anymore, right? So again, really common on these is the rupture of the pressure regulating valve. Obviously, keep an eye on that elbow piece. I recommend now, since they've come out with this TSB, that if you're going to the trouble of replacing this breather valve, let's replace that hose. It's not very expensive, and you don't want to have to go all the way back in there just to replace that thing. You're going to have to transfer it from the old one to the new one anyway, so you might as well just be better safe than sorry. Just replace it. The other thing is, too, there's another TSB. I didn't add that one in here, but on some of the later ones, they actually added a restrictor here to help control that crankcase, the amount of air that flows through here without changing the pressure. So that's something to be aware of also. You're definitely going to want to check your TSBs and make sure that you check them each time. Because very often they will update these TSBs with newer part numbers or newer instructions, and so if you have a TSB that's 2 or 3 years old, you may want to give us a call, put in a ticket, and see if we can, get you the latest and greatest, because they do change things or they add stuff. Something else to look for when you're replacing that valve, on the bottom, you have these metal plates. These are like one-way check valves, part of the system. Obviously, if you see one that's broken or that piece of metal is missing, don't put that back in. You're going to want to get a new one. If the membrane is squealing, and this TSB, they actually tell you to replace the membrane, but of course, when you go to buy the membrane, they tell you that you can't get the membrane separate. So you'll be replacing the whole valve. So just be aware of that, that these things do come apart, Here's another tech bulletin for map sensor fault, P0106. Now, before you guys get too crazy, I know that this part number for the engine is not in the list here, but I was just trying to pull an example of where you would go to find your control module part number and then your software version. Obviously, that doesn't correlate here, but just so you guys have an example of that. Software updates, unfortunately, right now, not something that we can perform for Volkswagen, Audi, but I will tell you that if there's a software update available, before you go crazy doing any more diag, you should definitely try to get that software update performed before you go crazy. So that map sensor fault, one of the reasons that these map sensors fail is because of the crankcase breather system. A little hard to see in this picture, but there's actually an oil film on this map sensor, and it has destroyed this map sensor. And you'll get this map sensor range performance fault, right? Not a circuit fault, because we don't have a circuit issue, but we have a range performance issue, meaning that it's giving some erroneous reading. That's impossible. So let's be aware of that if you do have an oil consumption issue, if you have a crankcase breather system that isn't working right, and you start getting some ancillary faults for sensors, you may need to pull them off, clean them up, or even replace them if they've been contaminated enough. So the only other thing that I wanted to talk about is just parts in general. A lot of companies are starting, these crankcase breather valves in the 3 liters and the 2 liters especially, are very well-known issues around the world. Every engine is going to have some issue with them. And the aftermarket is sort of taking note of that. And a lot of them are starting to produce aftermarket valves. And I will tell you that in my experience working here at Opus IVS and the calls that I get, more often than not, the aftermarket valves do not work correctly. And the reason for that, for the most part, especially on the 2 liters and 3 liters, but really especially on the 2 liters, I would say chain drive motors, is because there is that pressure regulation of the venting, right? Whether it's the boost side or your normally aspirated side, and the switching back and forth all uses very highly calibrated check valves and springs. And when they start mass producing these things in China, very often that calibration is not right. And so even though the part looks good and it fits well and everything, you'll put this part on and you'll end up with the same fault or new faults. And it's like, what the heck? It's like I put a new one on. My recommendation for these kind of components is to get factory dealer supplied parts. And I know that's not always possible, but there are some things, especially like that valve under the 3-liter supercharger. The price difference isn't so much usually that it's worth having to do the job a second time. So, better off to tell your customers, look, I'd rather put this factory part in. It's kind of buried. We don't want to risk an aftermarket part. And then the other thing to be aware of is, because there are these technical bulletins where you do software updates, and you update those parts, let's always make sure that if we're replacing a part, that it's not a part that requires a software update. Because if it is, and you put that new part on with the old software, your car's not going to run right. That's with the 2-liter, the 3-liter, because they've made so many changes. Really, your best bet is to get a factory one and make sure that either matches the one that you're taking off, the exact part number, or if there is a supersession, that you check your software and that it's going to be compatible. Because I have seen a lot of cars where they correctly diagnose that you got a bad breather valve, but they put the updated one on, and they've never done the software update, and then that's where we kind of run into an issue. So let's just be aware of that. All right. In conclusion, it's all about the oil. It's all about the fuel. It's all about the maintenance. I can't stress enough that using good oil, using good fuel, and maintaining your vehicle will prevent these systems from failing. You would be surprised. Crappy oil has crappy additives in it, and crappy fuel has crappy additives in it. And those things do not mix well with plastic and rubber and these very highly calibrated diaphragms and check valves and stuff. The other thing I would say, it's also about how your customer drives. If you're doing a lot of short trip driving and these things are not getting up to, not just operating temp, but really getting up to operating temp. I don't mean just that the needle says that you're at operating temp. I mean the needle says you're at operating temp and the fan is cycled a couple of times because it's gotten hot enough. That's real operating temperature. And if you're not really getting up to that, you're doing a lot of short trip driving, then you're never going to get these systems hot enough to get that good oil air separation. And you're going to end up burning a lot of oil. You're going to end up with a lot of carbon deposits. and you're gonna have issues. Now, again, I want to just reiterate, that these systems show a very clear progression of design. They don't like to make huge major changes. They do these incremental changes, and for the most part, the systems sort of work the same year to year. And if you understand that operation, then that is going to be your key to diagnosing when there's something wrong. So, that's what I believe, and that's kind of what I preach here at Opus when I'm on the phone with you guys. Try to educate yourself about the operation, because once you know the operation, then it's really easy to tell when it's not working right, because you know how it's supposed to work. So we'll just let you know about this webinar offer again. Of course, really, really good deal on that maintainer, and don't forget how important they are. And yeah, IVS 360, which is me, and all the other master techs here that are available to you. This is what we do. So let me open it up to questions, and see if I can answer any of your guys' questions here.
Hey, Andrew.
Hey, what's up, Chris?
What's going on? My head hurts. That was a lot of information.
A lot of information.
So we got a couple questions here.
Right.
We'll go to the back. But one thing that we didn't touch on the slides, but maybe you could touch on, is the rear main seal and breathers.
Yes.
And let's talk about that for a minute.
So let's talk about that, especially on the 4 cylinders, but I've seen it on the 6 cylinders too, 8 cylinders. When these things, when the pressure regulating valves go bad on these, very often what happens is you have an abundance of vacuum. And I don't mean just like a little bit, I mean a lot. And vacuum at that level is going to affect seals. It's going to affect drivability, of course, and everything. But I've seen these things literally rip the rear main seals from the plate that it's supposed to be permanently attached to, and create a vacuum leak. And very often, you'll be up top there and you'll be like, you have faults like you have a vacuum leak, and you have a lot of crankcase vacuum, and you do a good diagnosis on the valve is bad. Okay, you replace the valve, and the thing still isn't running right. You're still getting lean faults, and often, unfortunately, I will say that I have seen those rear main seals start to leak, and suck air, because that vacuum, it's going to look for any opportunity to pull the air in. And if you have any damage to that rear main from that excess vacuum, that's where it's going to go.
Yeah, and I would also like to add that rear main seal, that is a single-use seal, so it forms itself. So once it gets deformed, that's it. You're screwed. Game over.
That's it. Yep, it's over. And also, the procedure for installing those seals requires the use of a special tool. And I know, guys will balk at that and stuff, but what that special tool is doing is helping to spread the seal out, so when it goes over the crank shaft, that it doesn't get rolled, it doesn't get damaged, and that you are seating that seal on the surface correctly to prevent leaking. So it really is important to use that special tool, because you can damage the seals.
Exactly. Now, one thing I would like to note, for anybody who's watching this chat, go to the Files tab. All right. In that Files tab, you'll see two files, and those are what Andrew was talking about, where they're put together documents with normal known good crankcase vacuum specs, taken generally with a digital manometer at the oil cap or at the dipstick hole. And those are all known good specs. Again, Audi and Volkswagen, in their infinite wisdom, decided not to publish that information because it's not important to how vehicles work.
That's right.
Yeah, a metered vacuum leak is not something you need to know exactly what it's supposed to be. But I digress. So that is there. I advise you guys to take that. Now, I want to thank a good friend of mine put one of those together, Hans Jorgensen. He sits there, and this is just, he lives and breathes this stuff. So he put one of those together, and the other one was a mystery post on Diagnostic Network, and I don't even know who to give credit to, but they put that together, and we literally use that every day. Andrew, I know you come in the morning, and that is open on your desktop, ready to go.
It is ready. I keep that open all the time, and I try to add to it too. I often will ask the guys that I talk to on the phone, hey, if you got a manometer and you're measuring this stuff, let me know what you find, before you replace the valve and after, and you'll see on that on there. You'll see what the readings are for some of these aftermarket valves, and they are just all over the place. Totally not, consistent with factory valves. The data kind of bores out the fact that these aftermarket ones are just often no good.
So that brings up another one. What about Worldpac breather valves?
I would say that if you can get it from a dealer, it's worth the difference in price. I know that's not always possible, and often you have to, do what you got to do, or you're working with an advisor or a manager that doesn't, want to hear the factory part is better. But often, the Worldpac will sell you what they consider a factory part, and it may be made in the same factory, but often it doesn't pass the quality control that the ones that Audi buys do. And instead of throwing them away, as these manufacturers probably should, they sell them, for pennies on the dollar, and they let you take the risk of whether or not you're going to get a good one. So, somebody might have a great experience with Worldpac and get a good part, and everything is, honky dory, and the next guy could buy the same exact part, and that one is going to fail.
Exactly.
So, that's up to you what to do. But I would say try and go factory if you can.
So I would actually like to talk about one more thing here as well, and we can have a quick discussion because we've already been here almost an hour and a half. Is the blow by and the breather valves. So what we've been seeing, more so with the 6 cylinders, also with the 4 cylinders, is when you correctly diagnose a breather valve as being bad, you put the breather valve in, and it's a good breather valve, and then it goes bad again. So like what you've been seeing generally is because you have a lot of blow by in the engine, to damaging the valve, right, Andrew?
Correct. Right. Exactly. Because of the amount of vacuum, and I mean these things will pull so much vacuum on there that it just destroys stuff. It destroys check valves. It'll collapse hoses. I mean, it really can wreak havoc if it's allowed to pull just like a full vacuum. The other thing that I would also say is that if you're getting a lot of blow by, right, because maybe you have a piston ring issue or something, the breather system isn't going to be able to keep up with that, and over time, you're gonna sort of have more and more and more issues, if you kind of let it go, and that's what I see a lot with the V6s, is that it's not so bad. Oh, it's burning a little bit of oil. I'll just top it off, and then 6 months, a year down the road, we have some catastrophic failure, and that's kind of no good.
So one of the tests I would like, I would suggest performing, because again, we don't want to diagnose the car twice. We don't want an upset customer. Is like, let's go with the 2 liters, right? The 2 liters have that hose that goes from the intake manifold to the breather, the big hose, the vacuum hose. Mm-hmm. My suggestion is to disconnect that hose, plug both sides. If you have a plug for it, perfect. If not, you're going to hold it while somebody else starts the car. And this way, what you're doing is you're effectively bypassing the breather, taking the vacuum system out of it completely.
Correct.
At that point, take the oil cap off the car. Put your hand about an inch above the hole and see if you have pressure hitting you in the hand. Have somebody goose the throttle. Do the same thing. That pressure is blow by. Another thing you could do is if you want to put like a dollar bill or a piece of paper up there, look for the flutter. All right. If you have blow by in your engine, the breather valve is not going to be able to take care of that. A lot of these things are carboned up, and again, that trick that Andrew was talking about with the decarbonization with the top engine cleaner. Try running that through there. Best case, you look like a hero. Worst case, they're going to need pistons.
Exactly. And then I guess, my only one other thing that I would like to mention about breather systems is, if you have let's say you have an injector go bad, wide open, just dumping fuel. That fuel got to go somewhere, and often it ends up in your crankcase. And a lot of guys forget to think about the oil when they're fixing these vehicles, and you'll put a new injector in there. It's running great. But here's the thing: at about 160, 165 degrees of oil temperature, the fuel in your oil starts to evaporate and become a gas. Well, then what happens? Now your crankcase breather system starts to suck up that gas. So now, even though you've fixed your injector, right, and you don't have a lean condition anymore, and it was running great, now all of a sudden when the thing starts getting warmed up, you start getting a rich condition again. And you're like, well, I fixed the injector. Well, what you didn't do is you didn't change the oil. And that breather system is so efficient that it's starting to suck at a certain temperature that gas out of the oil, and you'll start getting a rich mixture even though you've fixed the fuel system. So just keep that in mind too. If you have a really bad breather system or a really bad fuel issue or a fuel leak into the engine, make sure you change your oil and your filter before you send the car on its way, because that once that thing gets hot enough, it's going to start off-gassing, and it's really going to have an effect on your air-fuel ratio.
Yeah. Great point.
So.
We had a question here from Matthew. I'm not even going to try to pronounce your name. It sounds something French, I think. He wanted to know about a good recommendation for pressure transducers or measurement tool for the small crankcase pressure. And somebody responded, AES way for pressure transducer. Now, I would like to take that on, if you don't mind, Andrew.
Yes, go for it.
I literally have a sign on my desk that says scope all of the things. Andrew's seen it. It's there. And when we moved the offices, I made sure my desk came with me, with my sign. So I am not going to say anything bad about pressure transducers. I love transducers. However, a digital manometer is $30.
Right.
$30. You get a spare cap from Worldpac. Drill a hole in it, put a fitting in it, and you have yourself a testing for every single Volkswagen and Audi. Well, most of them, because some of them have different caps that you have out there. You get one for BMW. Now you have this universal European crankcase pressure testing tool for $30 plus the price of a cap. You can use a pressure transducer for that, but a pressure transducer is $1,200 or $900 right. from AES Wave. Which I would love to use, but that's just busting out way too much.
Yeah, a little overkill.
Yeah, exactly.
So, all right.
So I think we're going to cut it off here because like I said, we're about an hour and a half in. If you guys have any further questions and you want something answered, webinars at opusivs.com. Again, that's webinars with an S at opusivs.com, and we'll get back to you with anything that we have to answer. And Andrew will get back to you. I want to say, Andrew, thank you very much for doing this. You're awesome. You look good over there in your beautiful white shirt.
Thank you.
So I just want to say, guys, good night.
All right. Take care, guys. Thank you for coming and watching our webinar.